We welcome you all for today's webinar on Longi Solar's panel for rooftop efficiency. I hope all our participants are taking good care and following all safety norms set by our government during these times. To know our audience better, I would like to have a quick poll now. I would request my colleague to launch it. Right, we've got a lot of response from this poll. We've got 20% rooftop developers. We have about 32% system integrators. We have rooftop installers, about 30%, and manufacturers also, which are 10%. Well, this sets the stage for today for our presenters. I will quickly run through the agenda for today. We have Longi Solar's team with us. Mr. Mohit Shrimal and Mr. Pavan Mathur will present about Longi's products and services. Mr. Arijit Mitra, lead distribution business, will be available to answer your questions later during the Q&A round. Mr. Pradeep Srikantan, representing Redington, will also be joining us and giving us an overview about Redington. I hope you all can see a Q&A box at the bottom of your screen. Please send us your questions in the Q&A box for all the panelists, and we will be answering them as and when possible during the seminar and post the seminar. Without any further delay, we start by introducing Longi Solar, the world's largest PV module manufacturer. Since its inception in 2000, Longi has ramped up its capacity. We'll hear more about their journey by Mr. Mohit Shrimal, a Senior Marketing Specialist. Over to you, Mohit. Mohit, you'll have to unmute yourself.
Yeah, you have to stop screen share so I can start.
Yes.
Yeah. So first of all, I would like to thank Solar Quarter for organizing this webinar for us. I also want a vote of thanks for Pradeep ji, who is our partner with Redington. To all the participants, thank you so much for taking the time out, and I hope all of you are safe in these unusual times. So I'm going to give a brief presentation about Longi Solar, the company, which is going to be followed by my colleague Pavan, who will give a brief introduction about our product for the rooftop. So Longi Solar was established in the year 2000. So we finished 20 years this year. And today we have over 30,000 employees working for us. A couple of things that we are very proud of is that we spend a lot on research and development. In fact, last year we spent about $186 million, and cumulatively we have spent about $800 million, which makes us the highest spender in R&D in the solar industry. Our revenue for 2018 was about $3.3 billion, and we just about a week back released our 2019 numbers, and our revenue and our profit have increased significantly. So just to give you a little scope into Longi, we are the world's largest module manufacturer. We are also the world's largest wafer manufacturer. In fact, in the mono wafer segment, we control 40% market share. You can say that one out of the two mono modules will be carrying our wafer. Another thing that we had launched HIMO 4, our bifacial series about a year back, and we have just completed over 3.5 gigawatt worth of orders shipped for our bifacial series. Longi is one of the most stable solar companies in the world, and all the top ratings across the industry, whether it's Bloomberg, whether it's PV Tech, they rate us as the most financially stable solar company in the world. In fact, in the PV Tech rankings, we are the only company which is AAA rated for the last 2 quarters, and that's even above all the tier 1 manufacturers, even above First Solar, which is a AA. So just to give you a little history about Longi, we started in the year 2000 with a formation of about 30 tons of silicon ingot. In 2006 to 2014, we became the world's #1 monocrystalline wafer manufacturer. I'll just want to bring in a story over here. So in the PV industry, mono is something that the market started with, and then poly came in and got the competitive advantage due to its lower cost of manufacturing. And again, you see a switch in 2017 and 2018, where mono has again become the larger market share among the two technologies. And this is mostly because of Longi, because we have worked very hard in few of the technologies to reduce the manufacturing cost of mono. So when Longi started the mono journey, the mono global market share was at 2%. And we are very proud that in 2018, the global mono market share crossed 50%. And in the year 2020, you will also notice that in India, which is a sort of a late technology adopter compared to countries like Europe, Japan, the mono market share will cross about 50 to, it should be definitely above 50%, and it's likely to cross 60% in India. So just in 2015, we entered the module business. It was a right extension to our wafer business. And today we are the world's largest module manufacturer with a capacity of over 25 gigawatt of module manufacturing capacity. That brings me, so our factories are mostly situated in China. We also have a factory in Malaysia, but the Malaysian factory only caters to the US market currently. And for India, we have factories in China that cater to the Indian market. Also, we have sales offices around the world. I think wherever there is need for solar modules, we have an office in that country. So we have an office in the US, we have many offices in Europe now, we have an office in the Middle East, all across Southeast Asia. And of course, our headquarters is based out of Xi'an, and we have a sales office in Shanghai as well. So this is our product portfolio. We started with HIMO 1, moved to mono PERC with HIMO 2 and HIMO 3. Currently in the Indian market, we are pushing HIMO 4, which is one of the best modules out there in the market. In some of the more rooftop-based markets, we have a product called HIMO X, which is mostly for the rooftop. But due to its higher price, and it's a shingling technology, because of its higher price, we haven't launched it in India yet. So this is a little bit about HIMO 4. It's based on our M6 wafer, 166 mm, and produces power ranging between 430 and 450 watts, depending on the power beam. We have this model is available both in monofacial and bifacial. So we certainly believe at Longi that bifacial is the future, and that is because the energy gain from bifacial products has overtaken the price difference between monofacial and bifacial. So on a LCOE basis, bifacial is a better product. Even for the rooftop, some of our top customers like Infosys have installed the bifacial product on their roof, and they have used they have whitewashed some of the roofs to increase the reflection. So this is the albedo effect that matters in bifacial. So how much sunlight can you reflect back from the surface onto the backside of the module will be the energy gained through the backside, and it depends from surface to surface. So the energy gain on grass, which has an albedo of around 20 to 25%, will be 7 to 9%. On a solid surface, it's 8 to 12%. When you move to concrete, it's even higher, 10 to 15%. And what I had spoken about before, how Infosys had put whitewash on there. So you can also install membrane on the rooftop, and that really, the energy gain really shoots and moves in the 18 to 25% range if you have a good membrane installed on the roof. So one can always do the cost calculation against the cost of the membrane and the extra cost for the bifacial module and see if the energy gain. In our studies, it has always been more profitable to push the bifacial module. But I think in India right now, people are more used to using monofacial modules. But later, in maybe 6 months to 1 year, we think bifacial will be the right choice. Another fact actually we are very proud of is that we offer the best power warranty in the industry. So Longi offers you a first year degradation of less than 2% and an annual degradation of 0.55% on our monofacial product. That is what we give in as a power warranty. But if you see the numbers on the right hand side of your screen, the actual numbers of annual degradation have been even lower. And this is for all our installations globally. Since we are number one, we have always rated number one in all the rating agencies and all the testing agencies, whether it's TUV, whether it's DNVGL, whether it's PV Tech magazine. Longi modules are always amongst the top performers in all the accelerated tests, in all the performance tests. So why we are always a technology leader and why we are proud to call ourselves number one is also because of our partners. We work with some of the best institutions in the solar value chain. Some of our industrial partners include companies like Harriers, DuPont, 3M. And on the research side, we are very proud to work with research institutions who have led the technology for solar, whether it's monoPERC, whether it's bifacial. We work with universities like University of New South Wales, CEI, and so on. So this is the future of Longi. This gives you a path from 2018 to 2021. We've already reached our 2021 expansion target. Our mono wafer capacity stands at above 65 gigawatt now, and our module manufacturing capacity is very close to 30 gigawatt. It's around 27 gigawatt currently. So this is our president actually gave the keynote address at the COP21 summit in Paris, and he launched a program called Solar for Solar. So while Longi understands that we are selling a carbon positive product, but we as a company we also want to be carbon negative. So he launched a Solar for Solar program in which Longi pledged to generate all its electricity for its various factories using renewable energy. So currently our factories are placed very strategically near large hydro plants, and they all are now moving into using solar energy solely for their production. We are very proud that we have joined a campaign called RE100, where global giants such as Microsoft, Apple have all pledged that they will use 100% renewable energy across the world for all their operations by 2050. And Longi commits to do this by 2030, to use only renewable energy for all our global operations. So this was a brief of Longi. I will now show you some of our showcasing projects around the world. So this is one of our floating projects. This is a ground-mounted solar plant in Yanqing, China. So this is another one in Shaanxi. Another thing I want to end by is that we've already supplied over 1.5 gigawatt worth of modules in India, and in the year 2020 we have a stiff target of over 3 gigawatt, which we already have in the pipeline to deliver. So Longi, India is a very serious market for Longi. We are very committed to this market, and we are sure and we hope that we will become #1 in this market. Thank you so much. Over to you, Smriti.
Thank you, Mohit, for your wonderful presentation. You have given us some key insights on how Longi's bifacial modules can increase rooftop efficiency. And we are also, it's actually great to know that Longi is committed to go 100% solar, and we will be looking forward and to this.
Thank you.
Yeah, I would like to now have some views from our audience on this upcoming poll question. Can we have that on the screen, please? So our question is about what our audience thinks that the government should focus on in the near future. We're getting good response for the poll results. So it's clearly policy and regulation which needs the maximum focus. Financing and reskilling and capacity building will follow next. So policy regulation, we have got a poll result of 82%. So 82% of the audience thinks that more focus needs to be given to this area. And remaining 25% think that financing should be given priority, and 21% think that reskill and capacity building should be given the priority. Thank you so much for joining in this poll. Now I would like to invite Mr. Pavan Mathur. He represents Longi Solar as their technical manager and will be the right person to help you with all your technical queries.
Thank you, Smriti.
Over to you, Pavan.
Thanks. Welcome everyone on this webinar. Just a minute. Yeah, so thank you, Mohit, for giving us a brief about Longi. I'm Pavan Mathur, as Smriti has just said. I'm Pavan Mathur. I'm working as a technical manager in Longi Solar. And I was just going through some of the questions in the chat box, and I can say that majority of your questions will be answered during the course of this presentation. We have designed these this presentation slides in such a way that majority of your questions, like what's mono, what's the difference between mono and poly, and the efficiency and everything, all those questions will be answered. Majority of them will be answered. So let's begin. So as Mohit has already spoken a lot about Longi, our company. Our company is actually into three parts. Into Longi Silicon, which is into manufacturing of mono ingot and mono wafer. Then we have a branch named Longi Solar, which is into the manufacturing of monocrystalline modules. And then we have a branch which is in China only, which is Longi Energy, which holds mono power plants. The particular reason why I'm again sharing the slides and these timeline details with you is that to tell you that we have extensive experience in the main heart of the solar module, that is the wafer, that is the cell. So we are a vertically integrated company. We were founded in 2000, and in 2020, we are doing extremely well as far as the module, every aspect of module is concerned. And we will see in the coming slides that how we are faring. Right. One another thing which shows our dominance is that we have 40% global mono wafer capacity in year 2000. It has not changed much in 19 and 22. So the first thing that comes to your mind when you choose a panel is why mono? Why mono? Longi Solar is a mono module manufacturer. So why only mono? Why you should go for mono? So let's go into the very basics. Now, right in front of you are the cell structures of two basic things. One is a monocrystalline module, one is a multicrystalline module, the cell structure of both the modules. So you can see that in left, in the monocrystalline module, there are no grain boundaries, whereas there are a lot of grain boundaries present in the multicrystalline module. Now, what is the problem with grain boundaries? These grain boundaries, they act as trapping centers for the charge carriers. The charge carrier finds it much easier to move in a monocrystalline module, and that's why it has a better efficiency. Now, if I have to sum up what are the major advantages of a monocrystalline module over a polycrystalline module, I'll sum up it as like the first thing, the first difference, major difference is the dislocation density. Now, the dislocation density is the number of dislocations in a unit volume, which are very less in mono and are comparatively higher in poly. So why this dislocation density is there, which is lesser in mono? That is because of the way the cell has been made, because of the manufacturing process. And that's the reason why I will discuss a little about the manufacturing process of the mono ingot and the poly ingot, because these differences between the mono and poly are directly related to the manufacturing process. The another thing is lesser iron impurities. I won't say that the mono doesn't has iron impurities. It has iron impurities, but the amount of iron impurities in mono are much lesser as compared to poly. The third thing is the carrier lifetime. The carrier lifetime is mono is much higher as compared to the poly. So because of these three defining factors, the mono always has a better efficiency. And efficiency is one thing which has to be taken care of really well when you are choosing a module for your rooftop application. So a better efficiency module will always be better while you choose a module for your rooftop application. So the reason why I have just given you the reason that why I want to discuss the manufacturing process of both the mono and the poly module. You see right in front of you, in the left side, there's a pipe-like structure, and then these granules. This is the feedstock for making both the mono and the polycrystalline module. Now I want to discuss a little about this granules, this basic structure, the polysilicon, how it is made, because this is the feedstock for both the mono and poly, and it is the treatment of these granules, the process difference, which makes a mono or a poly module. If we opt for the CZ process, we will have a mono ingot and a mono cell. And if we opt for the DSS process or the direct solidification process, then we find a polycrystalline cell. Right. So just to give you a brief how we get this feedstock, I just for the sake of your knowledge. Right. Silicon, which is the most abundant material on this Mother Earth, That's something around 27%. That's highest after oxygen. Oxygen is 46%. Silicon is 27% on this Mother Earth. Now, we have this silica is hidden in this form of silicon oxide. Now, the material that we need for making solar cells is high efficiency silicon, that is electronic grade silicon. So how are we going to arrive at electronic grade silicon? So there are two major processes. First, we convert the silicon oxide into metallurgical grade silicon, which has the efficiency of somewhat around 98%. And then this metallurgical grade silicon is converted into electronic grade silicon. So if we start the process, silicon is added with carbon or the sources of carbon like charcoal, coke, and they are put into an electrode arc furnace. And the temperature in that furnace is really high at 1800 degrees Celsius. The output which we have is a metallurgical grade silicon, the efficiency of 98%. This metallurgical grade silicon is also utilized for manufacturing some of the lower quality solar cells after various chemical refinements. Now, to have a better efficiency in the cell, this metallurgical grade silicon is treated with anhydrous hydrogen chloride. So distillation is done and at 300 degrees Celsius, and the result is normally a silane product. And more often we get trichlorosilane. I mean, majorly the manufacturers use the process we get, the output we get is trichlorosilane. Now there is again a treatment of this thing, and in the Siemens bed reactor, eventually we get electronic grade silicon, which is the feedstock for both mono and poly module. So this is electronic grade silicon. Now we opt for the CZ process to make a mono wafer. So what is the CZ process? What we do is that we have a furnace. Now this furnace is also moving. In this furnace, we put the impurity of boron or gallium. I will discuss in coming slides that what impurity do we use to make a p-type wafer. And then we add this feedstock to it. Now, this furnace is heated up at a high temperature and it comes into molten form. So after that, from top side, a seed crystal is dropped, and normally, very slowly, the seed crystal is pulled up. Now what we get is this ingot. I have a very interesting video for you which will make the CZ process very clear to you. So this is the furnace in which we have added impurities and the feedstock. Now this thing is heated up and it comes in a molten form. Now what we do is, in the second step, is that we add seed crystal to it from the top side. Now this is the seed crystal which is coming down, and the seed crystal is slowly dipped and then taken up. So this process is done at various temperatures, and this churning is there, continuous churning is there. Slowly we are taking out this seed crystal, and eventually the temperature is also controlled, so we get this silicon ingot. So this is our final product of silicon ingot. And what we do, just to give you a brief idea, because somebody asked in the chat box that how we make this poly. So what we have is that we have big crucibles. In those crucibles, we add our polysilicon and the impurity of boron. Now we heat this square crucibles on high temperature, then we allow it to cool down. After cooling, we get these square kind of shapes, and you can see it and you can observe it that because of the shape of the ingot, the shape of the cell is also different. You know, if you are using a mono ingot, and if you want to draw a square out of it, then a lot of material will be wasted. So instead of making it a perfect square, we just shove off the edges, and eventually we have this kind of octagonal kind of a structure, wherein in a polycrystalline ingot, multicrystalline ingot, it is already in square shape. So when we cut it, it remains in square shape. Now this this monocrystalline module with all monocrystalline wafer, with all the benefits that I stated earlier, it has low dislocation density, it has no grain boundaries. So no grain boundaries, lesser charge trapping centers, and as a result, a better efficiency. So again, this slide shows the basics difference between the making of a monocrystalline wafer and a polycrystalline wafer. We use the Caesar process, then slicing is done, edges are shaved off, and we get a wafer of and a cell of mono. And if we just put this material into a crucible and then we make squares out of it, we'll get a polycrystalline module. Cell, sorry. So this is a brief about the products of Longi Solar. In May 2016, we came up with HIMO 1. It had the PERC technology and it had lower degradation technology too. So we always had this advantage of better lower degradation actually. In April 2017, we came up with HIMO 2. Now the advantage it had over its predecessor was bifacial. It was bifacial, right? So it was having bifacial, it was using bifacial PERC technology, and it had glass-to-glass encapsulation. In May 2018, we came up with HIMO 3. It was having all the benefits of its predecessors, plus the benefit of using a half-cut cell, right? So we will discuss each of these things like the PERC technology, because many people are asking about the basics of the PERC technology and the bifacial thing and everything. So we will, in coming slides, we will discuss each one of them. What is the benefit of using half-cut technology and everything. Our latest offering, which was offered in May 2019, is HIMO 4. Now, it has all the advantages of its predecessors, like it is available in monofacial and bifacial. It has the half-cut. It is using a split cell technology. It is having the advanced PERC technology. And to add to it, it has M6 wafer, which is the bigger wafer. Earlier, we were using a 158 mm wafer. Now we are using a 166 mm wafer. So what are the advantages of using this bigger wafer? We will see now. So if I have to sum up the advantages for the customer, I'll put it like, since we have improved in the cell manufacturing process and the efficiency is improved, our process too has improved. Our process of making the module has also improved, and that has resulted in the decreased BOM cost because of our experiences and our lesser changes requirements in using the 166 mm wafer. So that will clearly reflect on the overall BOM cost. And then this cost, this benefit will be reflected to the customer in the price that we offer to them. The another benefit of using bigger cell is that there will be a lot of saving in the BOS. Since from HIMO 3 to HIMO 4, the voltage of the module has not, the VOC of the module has not changed. So the string length is same, but the power output from the same string length has increased. So we need lesser pile foundations, we need lesser cable, lesser labor cost is required less. So all these benefits will be highly reflected in the BOS savings. Right, our module is capable of being installed at all the trackers too. And the input current matches exactly with the string inverters. Now, this is about the bifacial module. The bifacial module in the backside has no C-frame design. And because of no C-frame design, there will be no hotspot because of these frames. We use 2 mm cells in front and back in a bifacial module. In a monofacial module, we use a 3.2 mm glass. The bifaciality is also wonderful. It's glazing 75%. And they are adequate mounting holes so that these modules can be installed anywhere with any tracker application. We are currently we are offering this thing in 6 bus bar, and soon we are coming it with 9 bus bars too. We'll also see the benefits of the various things that we have used in our module in the coming slides. One more thing, the efficiency of our module is wonderful. It is at 20.9%, and we have adequate capacity for you guys. So all your needs will be satisfied. So we will discuss the benefits of HIMO 4 in 4 parts. Our module has excellent power generation performance. Now, why it is getting those, what are the parameters that are enabling our module to get this excellent power generation performance? The next thing will be reliable bifacial gain. So I'll start with the basic, what is a bifacial module, what is the structural change in a bifacial module, and how we are achieving the reliable bifacial gain. What are the factors affecting the bifacial gain? The third thing we will discuss is the reduced BOS cost. How the BOS cost has reduced, what are the enabling factors which are helping us to reduce the BOS cost, eventually the customer to reduce the BOS cost. The fourth thing, and one of the best things about our module is the leading power and quality warranty that is the lowest in the industry, the best in the industry actually. The degradation is the lowest in the industry, and our module is offering the best degradation in the industry. Now, this module has 6 bus bars, and we are coming with 9 bus bars soon. So what are the benefits of having more bus bars? More doesn't mean that you cover whole the cell with bus bars, but optimizing it, we have, after our optimization calculations, we have come up with the 6 bus bars and 9 bus bars to soon. So 6 bus bars, if you have the more bus bars, then what happens is that the electron or the charge carrier, which is generated at the far end of the cell, has the chance to find this highway of ribbon, and it has the chance to contribute to the current because of lesser internal resistance it faces. So because of lesser internal resistance, there will be more current that will be produced by the cell. Now, in the 9 bus bars, we have increased our bus bars, but at the same time, we have reduced the width of the bus bar. So the side which is facing the sun, so area which is facing the sun is not decreased. We have done some careful optimizations, and we have gone through various tests that the amount of area that is facing, that the cell is facing towards the sun, it is not being reduced at any point of time. Another thing that we have added in it is that instead of using a flat ribbon, we are using a circular ribbon. Now, because of this change, what we have done is that, because of the change that we have done is that the light which is falling on the surface is getting reflected back to the surface of the cell. The light which was falling on the bus bar is getting reflected, and it is being reflected back at the cell. Because of this technical advancement, the wattage of the module has considerably increased. Another benefit of using more bus bars is that the efficiency of the module the mechanical ability of the module increases. The efficiency definitely has increased. The mechanical ability of the cell has increased. So I have just covered all these points, that the internal resistance has decreased, and the ability of the mechanical ability of the cell has increased. Now, we proudly say that our module has the lowest LID. Right, so we will first discuss that what LID is, what PERC technology is, what are their benefits, and what are the changes we have done in our module to encounter the LID problem. Right, so we will first discuss what is PERC. Now, PERC is passivated emitter rear contact technology. So to understand the PERC, so that everybody can understand, I'll just start from the very, very basic. What happens in the left side, you have the diagram of a conventional cell, and the right side you have the Perk cell. So in conventional cell, what happens? The light is coming, the energy photon is coming from the top side. It passes through the emitter region or the N layer, and then it enters in the depletion region, and it liberates an electron and a hole pair, right? The electrons, the charge carrier will move upwards and the hole downwards. Now, what happens is that not all the photon which is coming from the sun follows this path. It happens all the time, so we can't say many, but many times what happens is that the photon which is coming from the sun passes through the N layer, passes through the depletion layer, passes through the whole base layer, and just comes to the aluminum metallization without doing any effective work, without imparting its energy in the depletion region. So this photon which has fallen on the surface of the module still got wasted because it just came and it passed through all these layers and it entered the aluminum metallization. So we should find some way that this photon which is coming from the sun gets at least a second chance of providing its energy into the depletion region. So what we have done, we have come up with a dielectric Perk layer which is just above the aluminum metallization, right? And it is in the lower half of the base layer. So now what happens is that the photon is coming from the sun. If it has passed through the N layer, depletion region, and the base layer, it will have a chance, there is a chance that it gets reflected because of this dielectric Perk layer, and it goes back into the depletion region. So it gets a second chance of giving its power to in the depletion region and contributing to the current. This is one of the benefit of Perk. Another benefit of adding this Perk layer, dielectric Perk layer, is that the electron which is generated at the far end, like the electron which is generated in this near this aluminum metallization, they have the tendency to directly jump into the aluminum metallization without going towards the emitter region and the bus bar, right? So instead of going up, they just jump in the aluminum metallization. And this is called recombination. So if we have added a dielectric Perk layer, that electron will not jump into the aluminum metallization and it will travel the path, right? So if you sum up these benefits, one is the reduction in this recombination, and the electron gets a second chance to move upwards and to contribute into the current. So the benefit of Perk technology is very much visible in the infrared end of spectrum, when the wavelength of light is between 1000 to 1118 nanometer, right? So this is normally in dawn and dusk. So it has two things. First of all, it improves the cell efficiency because this aluminum metallization layer is not getting heated up. The second thing is that recombination is reduced, right? So it is actually acting as a shield. So this was about the Perk technology. The next thing is the light-induced degradation. So what actually is light-induced degradation? We will just go step by step. What is this problem? So if we go by the definition, when the solar panel faces the light for the first time, there is a change in the Fermi energy level of the module, and because of which the efficiency of the module decreases. So I'll put it in another way. When the solar module first faces the sunlight, its efficiency decreases. And why it decreases? Because of the change in the Fermi energy levels. Now, why this Fermi energy level is changing when the module is first exposed to light? The chemical change which is enabling this Fermi energy level change is that there is a boron oxygen complex which is formed in the module. And this, because of this, the Fermi energy level changes. Now, why this boron and boron and oxygen complex is formed? From where did boron came, and from where did oxygen came? So boron is utilized as a dopant while we make the p-type material. In the very first initial process, during the CZ process, we add boron to it. Right, and oxygen was also utilized in heavy concentrations in the CZ process. So boron and oxygen both are present in the cell. And when the light first falls on the module surface, these boron oxygen makes a complex. Now, these boron and oxygen complex, it acts at an intermediate energy level. Now, what happens because of these intermediate energy levels is that the charge carriers which are liberated, they are trapped by these boron oxygen complexes, and the charge carrier just gives up its energy in the form of heat in the boron oxygen complex, and without doing any useful work. So because of this boron oxygen complex, the efficiency of the module decreases. Right, so what should we do to reduce this boron and oxygen complex formation? We have to either reduce the boron, we have to either eliminate the boron or the oxygen. Now, oxygen, because we follow CZ process in the manufacturing of monocrystalline module, oxygen cannot be removed. So boron can be removed. So instead of using, in Longi Solar modules, very proudly say that instead of using boron as a dopant, we are using gallium as a dopant. This is one of our patented technology. And you must have seen the PV magazines. It was in the news also that we have patented this technology of using gallium as a dopant. So no boron, no boron oxygen complex formation, and no LID loss. Still, there will be LID loss in the module, but very less. And we very proudly say that the LID loss is the least in our modules. It's only 1.5%. Also, yearly degradation is least in Longi Solar modules. You can compare all the modules and you'll find that the LID is least in Longi Solar modules. So without wasting much of our time, we'll move to another benefit of Longi Solar module. We use half-cut technology. Majority of the players are also using half-cut technology. So I'll just introduce you what are the benefits of using the half-cut technology. You know, the equation of power loss is equals to I square R. So it's directly dependent on the current. So when we cut the cell into half, the current carrying in it is reduced by half. And since power loss is a factor of 4 of the current, so if the current is reduced by half, the power loss is reduced 4 times. And because of this, there will be less power loss in the module. Also, it enables, because of this change, the hotspot temperature of the module decreases. You know, hotspots, even if they are created, you know, there is very less chance, because the current has decreased, the formation of hotspot is still, the chances of formation of hotspots will be really less. But let's suppose because of some shading on the module, there's a formation of hotspot. The hotspot temperature will be really less, and because of which the chances of the damage to the module will be really less. Another benefit is that the operating temperature is decreased. And because of the reduction in operating temperature, the efficiency of the module will increase. The overall performance of the module will be increased. Now, since I just said that operating temperature has decreased, the output power will increase because our module performs much better in partial shaded conditions. We will see a video that why our module performs much better in the partial shaded conditions because of the configuration. I'll show you a video that what is the change in the configuration that we have done, that our module is performing much better in partially shaded conditions. And also because of all these technological advances, during high radiation conditions, the performance of our module will be much, much better. Also, we are using split JB technology. Now, what are the advantages of using split junction box? The first thing that comes to my mind is if the junction box is split and it is not at a central location, the metallization required to connect those bypass diodes will be really less, right? So if there is less metallization, eventually there will be less internal resistance the electron will have to face, and if there is less internal resistance, the efficiency of the module will definitely increase. Now, another benefit is that of splitting this junction box into 3 parts is that it still has 3 bypass diodes. The benefit is that, you know, if one bypass diode is getting heated up, if there is a single housing, then this bypass diode will also transfer its heat to another bypass diodes. Now, if there are splitted into 3, if these diodes are split into 3 housings, then if one bypass diode is getting heated up, it will not transfer its energy to other bypass diodes, and the overall temperature of the housing will decrease, right? So tests have shown that there is significant reduction in temperature, the heat build up behind the junction in the junction boxes, right, because of this split technology. So there is something around 15 to 20 degrees Celsius lesser heat generation. So this is one advantages of the split junction box technology. Now, this is the path the current takes in our module, right? This is self-explainable. Not much is required in this thing. I'll show a video. I'll show you a video that why using this technology or this type of framework, what are the benefits, right? So this is a video which will make you realize what is the benefit of using our modules. Now, we see that these modules are normal modules. These are not Longi Solar modules. These are normal mono modules connected. When these are working in normal conditions, the output current is 8 ampere, for example. Now, when there is shading in the lower half, what happens is that since all these modules are connected into series, the output current from the string will be 0. Now, if you use, instead of these normal modules, if you use Longi Solar modules, which is half cut, now, even if there is shading in the lower half, still the current generation from the module will be 4 amperes, which is half of 8 amperes, right? So you'll not lose all the generation from the module, even if there is significant shading in the lower half of the string. I hope this thing is clear. Now, because of all these technological advances, we have received these prestigious awards in 2017, 18, and 19, which was the UV Green Lens Energy Yield Simulation and Outdoor Test Award. Now, these are some PV magazine tests which were conducted on our Longi Solar modules, and they clearly depicted that Longi Solar modules were having more generation than any other module. Now, this is again one PV magazine test which said that a Longi PERG module had much better generations. They did their tests, and these slides can be shared with you. And so you can do your math and you can see these calculations in a better way. Now we'll quickly move towards the second part, which is the reliable bifacial gain that we offer in our HIMO 4 modules. So we'll first discuss what is a bifacial module and what is the basic design change that we have done in a bifacial cell. So a bifacial module is a cell which is a module which is capable of generating power from the rear end, also from the backside also. It is capable of generating power. And what will be the gain from this change depends on many things, actually. It's not that it doesn't depend only on the albedo. It depends on various things. like the installation conditions and the designing of the system. So we'll see all these things in coming slides. We'll first focus on the design change that we have done in the bifacial cell. So in the right side, the right image, I'm sorry I have not mentioned it, which one is bifacial and which one is normal. In the right side, we have this normal cell image, right? So you see there is a complete metallization on the rear side, right? So no light can enter from the rear side. So what we have changed in bifacial module is that instead of using this rear side complete metallization, we have added a local aluminum gate lines. Now you see that it's not completely metallized. It only has aluminum gate lines in the rear end. So there is opening from the rear end also, which will enable the cell to enable the depletion region to get power from the backside too. So this is the basic design change in the bifacial module, right? So the next thing is again bifacial PARC technology design that we have adopted. It has silicon nitride coating as an anti-reflective coating on the top, which prevents it from pollution and decreases the light reflection. Then we have soldering pads in the rear side. Also, we have the silicon nitride anti-reflective coating, aluminum oxide passivation at the rear end, and at the top end also. So this is actually a basic design of the PARC technology. Now, just for your understanding, the mechanism of bifacial energy gain, how we calculate the bifacial energy gain. So energy gain is not only dependent on the module, on the module. It depends on the interrow spacing. What is the albedo? I'll also define what is albedo, because somebody asked in the chat box that please define what is albedo. So it depends on albedo, the height of the module or the height of the structure. But again, then we have to optimize our calculation. We have to make our calculations, because when we elevate the height of the structure, it has its own financial implications. Also, we have to take care of the irradiation conditions. When we choose the site location, we should also understand that what is the irradiation condition of that particular location. What is the amount of reflected light from the clouds? So this bifacial gain can be simulated with the help of PVSYST software, right? So these are some of the design parameters which have their effect on the bifacial gain. One is albedo, one is height, one is the ground coverage ratio, and then the DHI. So before that, I'll explain what is albedo. Albedo is the light which is reflected from the surface of behind the module. The surface which is behind the module, the light which is getting reflected from that surface, right? So the reflection is different for different surfaces, right? So albedo can be defined as the light reflected from the surface divided by the light falling on the surface. Right, it's different for different surfaces. Like if we have grass behind the module, then the albedo will be different, because different light reflected from the module will be different. If there is dry sand, the albedo will be different, and similar for new snow. New snow has actually the highest albedo. It is 0.82, right? And red tiles have the albedo of 0.33. Now, bifacial gain, if you see the graph which is right in front of you on the right side, the graph shows that what is the relation between the bifacial gain and the albedo factor. Now, albedo, if we increase the albedo, if there is albedo of 0.2, then there can be a bifacial gain of something around 7%. It depends on various other things. To arrive at this graph, we have kept other things constant, and then we have made this graph. So you can see that at 0.5 albedo, the gain is something around 15%. And in practical applications, I can assure you that the gain that we arrive at from the PVSYST calculations, the actual gain is much higher than that. when we have interacted with various peoples, or we have seen from our experiences in at various locations, the actual gain that we receive from the bifacial modules is much higher than the one which is calculated by the PV assist analysis. Next thing is the relation of bifacial gain with the height of the module. Now, if the height of the module is 0.3, the bifacial gain is really less, because not much light is getting reflected back to its surface, its rear surface. And what we have seen is that at 1 meter, if you keep the height of 1 meter of the module, then the bifacial gain normally gets constant. So that means that if you increase the height of the module even after 1 meter, there is no considerable gain in the bifacial gain. Right. So this one is, sorry, I have to hurry up because we are already late. Then the GCR again, if it is reduced, then that means the ground ground required is more. So again, this thing has its own financial application, and the graph in front of you shows that how bifacial energy gain is dependent on the GCR. Another thing is diffused horizontal irradiance. I have already said that in previous slides that you should take care of the site location, but what is the value of DHI at that particular site. So we have done our calculations for two different DHIs, for 63% and for 31%. And we have calculated that at the various ground albedos, the left graph shows that at like if the DHI is 31%, then at the ground albedo of 0.2, the bifacial gain is something around 8%. And if at DHI, if the DHI is 63% and the ground albedo is 0.8, then there can be a extremely high bifacial gain, which can be something around 32%. So these are the system design parameters. Now we have tried and tested our products at various locations in various conditions, like in Saudi Arabia, extreme heat conditions, in Chennai, humid conditions, in Henan, China, in Fairfield, USA, in Livermore, USA, and various locations of USA. And we have found considerable bifacial gains at various locations. So this is one of our pilot projects in Chennai, in our country. The bifacial gain that we observed was 19.2%, and the white granules were behind the module. The module was tested against the various type of modules, the bifacial pug, the N-type bifacial, and we observed that our module provided a bifacial gain of 19.2%, which is really high. Now this one was done by IDTC at Livermore. This one was bifacial plus tracker. And you can see that the albedo was also not much, 21.4%, actually 0.2%, 0.2, and we arrived at a bifacial gain of 8.3%. This was done in Kubuchi Desert, and they really got a really good bifacial gain because they used bifacial modules plus tracker. So in desert conditions, we got almost 25% of bifacial gain, which actually is really, really good. Now, we have shipped, as Mohit has stated in his presentation, that we have shipped our bifacial modules globally in Egypt or Australia or US. Everybody is using our bifacial modules, and they are extremely happy with them. The third thing is the reduced BOS cost. That what are the enabling parameters because of which the BOS cost is reduced. Now, first things first, our modules are very convenient to install. Ample amount of holes are provided for their installation, and they are really lightweight, so very easy to handle. Sorry. So as I said earlier, the VOC of the module has not changed. If you compare with our HIMO 3 module, which had this 158 mm cell, we have migrated to 166 cell. The VOC we have kept constant, right? So the string length has not changed, and all the related parameters have not changed, but the power of the string has gone higher, right? So you can see a considerable amount of saving in the fixed mounting structures needed, in the pile foundations needed, and in the cables needed, the string inverters needed. So there is a considerable amount of saving in the BOS. Now, if you compare our module with other mainstream products in the market, you'll find that the degradation of our module for the first year and for the subsequent years is the lowest, which actually is the most enabling factor while you choose the module for your rooftop applications. You know, it's one thing which really matters the most. Degradation makes a significant difference in the power generation that you will receive for the 25 years, the course of 25 years. So every percentage count, and LID, which is considerably low in our case, it's a difference of somewhat around 0.5% in the very first year. And I can also say you with a lot more certainty that our modules in actual conditions have really less degradation in the real field conditions. Till now, we have not faced a single claim for the module degradation. Our modules have been installed at the various conditions and the harshest of the conditions, weather conditions. And till now, we have not arrived at a single case of module degradation, claim for module degradation. So we have to keep check on the time. The last thing is that we offer the leading quality warranty. You see, as I just discussed, for monofacial modules, our yearly degradation is 0.55%. And for bifacial modules, it is even lesser, 0.45%. And these values are best in the industry. So a lesser yearly degradation will help you in getting more and more generation from your modules. Again, our modules were tested by various testing agencies. This one was Renewable Energy Test Center. They tested our modules for reliability, for performance, for quality, and they found that our modules actually qualified really well, performed really well on all these testing parameters, and we were awarded the highest achiever award. Now, to end our slide, to end my presentation, our modules are very trustable, very bankable. In year 2019, we had AA rating from the Bloomberg, and in 2020 Q1, we had AAA rating. I think we were the only company to achieve this AAA rating. On this good note, I would like to end my presentation. I will tackle all these Q&A questions that are coming up on the chat. I'll try to answer these questions if I can in this course of in this remaining time. If I can't, I'll try to answer them on with the help of my email. So thank you all. Thank you, Smriti.
Mr. Pavan, please be with us for a while. We'll launch our next 2 polls, and these questions are related to your subject. So we would like to hear your views on the results.
Sure.
So our first question is, which solar module technology you prefer for your rooftop solar? Is it polycrystalline full cell, monoperk full cell, polycrystalline half cut cell, monoperk half cut cell, and monoperk half cut multi-bus bar cell? Our second question is, which of the following solar module ratings you prefer to use for your rooftop solar? So people are taking time to think on their answers.
I think it's much better if they think and answer.
Yes.
More chance they will use Longi if they think.
Okay, we've got the results now. 15% of the audience says polycrystalline full cell.
Okay.
10% of the audience says it's mono PERC full cell. 11% says polycrystalline half-cut cell. 25% say mono PERC half-cut cell, and 39% says mono PERC half-cut multibusbar cell. So what are your views on this first poll result that we have received?
You know, without wasting a second, I would love to go with the majority.
Okay.
No,
Right.
but definitely what people have chosen, what the majority of the people have chosen is actually the best thing. Because when you enter the rooftop segment, the efficiency and all the benefits which were given in the last option are actually really required. Multi-bus mono is really a winner for a rooftop segment because of the efficiency, and especially Longi modules because of their lower weight and the lower degradation that we offer. So yes, people have chosen the right thing.
All right.
So I'll just add that in the rooftops the space is limited, so you can generate much more power using our high power beams and half-cut technology, because on the roof in many places there is shading effects. So if you use half-cut technology, it's much more beneficial, and due to the space constraint, you can produce more power using the same space on the roof if you use high power beam modules.
I think we've received some questions on those lines as well. So thank you, Mohit, for answering that. Our second question was, which of the following solar module ratings you prefer to use for your rooftop project? So here the clear winner is above 430 watt power, which is what we are talking about. So
yes. Thank you. Actually, this shows that people are listening.
Yes, whoever has answered that can go to Redington. They have stock available.
Okay, so Mr. Pawan's presentation will be shared with everyone post this webinar, and many of your technical questions that we are receiving will be answered soon. Moving on to our next segment, Redington is a 25-year-old organization providing end-to-end supply chain solutions for solar. They are pan-India distributors for Longi Solar. I would like to invite Mr. Pradeep Srinkantan to give us an overview about Redington India. So before we start, can I request you to keep your camera and mic on, please?
Hi. Yeah, it's on now.
Yes.
Hope I'm audible now.
Yes, you are, sir.
Yeah.
So before we begin, I would like to ask a question to you. What are your views on the current distribution market scenario?
Yeah, as you know, there are a lot of in the last 1.5 year, 1 to 1.5 year, you have seen that there are a lot of issues that have been cropping up now and then in the solar industry. Starting with it all started with the implementation of GST, and then the customs classifying the solar panels wrongly, saying that it is a DC power generator, and saying that you need to levy the duty, the basic custom duty on that. So continuously there are a lot of hurdles or constraints that the industry had to go through in the last 1.5 years. But yeah, it's good to see that these issues have cropped up, and there has been a solution for this. Overall, considering the segment, which is the utility scale and the distributed power generation rooftop, utility scale has its own set of issues which they are facing. The rooftop has its own set of issues. Overall, if you look at today in India, the distributors, so-called, because Redington being an organized distribution company, we had to face a lot of challenges in fitting in this very unorganized segment. Solar today is a very fragmented and a very unorganized segment, which is still in the growth stage and still growing. So considering this, we have been able to somehow maneuver all these challenges that we have been facing. But yeah, finally, what we have also seen is that people, a good set of customers or EPC companies want to work with distribution companies that are very stable in terms of supplies, very stable in terms of holding the prices, competitive prices, and also distributors who are financially strong enough to support the claims when there is a claim that is made by a user or an EPC company. It's very important that as a distributor we go back to the manufacturer or the supplier, OEM supplier, and say that, okay, this is the problem, please come and support, we have a problem. So that way the distributor's strength to negotiate with the manufacturer and help both the EPC company and the end user secure their investments. So this is what we have been seen, and to a great extent we have been successful. But also we have seen on the other side there are a lot of small time dealers, distributors, resellers who come in between and want to make a quick buck out of the industry. And anyway, that is all. That will be there in a very unorganized segment like solar, which is today. So hopefully going forward, we expect that the sector should get more organized. So that is what we are also working towards, so that the entire industry is benefited.
That's great to note. I think definitely all the consumers and installers would seek your assurance when they are buying Longi modules. Over to you now for your presentation.
Sure. Hope the screen is visible now.
It's visible. Please go ahead.
Yeah. So I'll start. First of all, I would like to give a brief background about why we have come together with Longi here for this webinar. Redington is basically a multi-brand distributor, a global distributor, and one of the largest distribution companies in India. So we have been engaged with Longi since 2016. When we started our solar business in 2016, it's been 4 years since we started our solar journey, and we started off with Longi in starting maybe beginning of 2017, and at those days it was mostly mono, just standard mono products which Longi had, not the mono perk or the mono perk half cut or the bifacial which we are talking about today. So it was standard mono full cell modules of 340 and 345 watt peak. That's how we started our journey with Longi, and we are very happy to say that we have supplied a good number of standard mono products, Longi products, across states which are known to be the hottest states in India, like Rajasthan, Gujarat, and many other states. And the feedback has been fantastic. The performance, the feedback on the energy generation and the quality, people they come back to us asking for Longi. So in between there was also a time in 2018 and 2019 where Longi was actually moving or upgrading the technology from standard mono to mono perk, and we found a lot of customers come back and ask, they want Longi mono 340, 345, but it was transition was happening at Longi, and we were unable to support a few clients. So it's a good thing that people come back and ask for quality. So with that as the background, I would like to start, give a brief about our corporate, what Redington overall is, and what we do in solar. As you see, Redington, we are a large distribution company. The number one technology 28,200 partners. So we are an emerging market player globally and also in India. So this is our distribution, what the model of distribution, the way we operate for our other businesses, which is predominantly IT, consumer and mobility. So we are in different businesses at Redington. So we have the vendor who is the supplier, the distributor, and then we have the system integrator, retailer, reseller, the e-commerce player who take the products to the end consumer. So how we are a value added distributor? What value the our brands whom we promote derive out of Redington, and what our channel partners derive out of Redington. So market knowledge and access, demand generation. These are the advantages that the brands get when they work with Redington. As channel partners or customers, in this case, in the solar industry, are EPC companies or system integrators who work with us. So it's a one-stop shop for them. They don't have to waste time scouting around in the market for a good product. Inventory management. Today, the solar industry is, as everybody knows, it's highly working capital intensive. So very difficult for EPC companies, system integrators to invest money for a long time and wait for the modules or the components to arrive. So we give them a better inventory management because we have stocks. Financing to certain businesses, we also offer credit in the market, but solar is predominantly a non-credit business at Redington. But still, we do encourage credit facility for customers who are very strong in terms of their financial background. Logistics, we have a complete, full-fledged logistics company, which is a 100% subsidiary of Redington. So entire supply chain logistics is taken care of. Order consolidation, as you know, this is what is our strength. So we today we cater to almost like more than 1,000 system integrators across the country. So even a smallest of the smallest system integrator comes to us to buy a panel. We even supply one panel. If somebody wants a single panel, we encourage them. So technical support and training, something which we are doing. It's an ongoing thing. This is our product life cycle. What we do, we are present in the from the distributions, starting from the distribution. Like distribute, we have Redington, which is the distribution company. Logistics and supply chain, which is handled by our company, 100% subsidiary of Redington, ProConnect Integrated Logistics is the company that handles the complete distribution chain for supply chain and distribution for Redington, and also offers services for third-party customers. Then Ensure Support Services. Ensure is the company which is again an 100% subsidiary of Redington and handles all the service-related activities post supply, post the sales of the product. So we have a lot of tie-ups with brands like Apple, where this Ensure Support comes into picture. They sign up service contracts and they offer the services for all the products that we distribute. So this is our mission, is to offer a robust technology-powered platform to enable a seamless flow of products and services. So as a distribution company, we want to ensure that there is seamless flow of products and services to the market. Our values: adaptability, collaboration, know-how, objectivity, simplicity, trust, and transparency. So these are the values on which we build our business. So as I said, we are a global, we have a global presence in about 37 markets. So these are some of the brands that we have been working for many years now. For all our other businesses, solar is our emerging business at Redington. So this is our strength in terms of what we are. We deal with more than 215 plus brands across all our businesses. 38,000, more than 38,000 channel partners who work with us across all the businesses. 4,747 employees, 37 markets, sales offices, 80 plus sales offices, 245 plus warehouses. So we have warehouses in India. We have warehouses in all major cities you name. In all the states we have a warehouse. Then service centers. So this is how we have grown from 1993 to what we are at present. So this is our board of directors. This is our executive team who handle the senior level, handling the entire operations at Redington. So in terms of business, as you see, we are present in India, Middle East, Africa, Turkey, Singapore. All these places we have our offices and warehouses available mostly. And these are the business segments we are in: IT consumer, IT enterprise, mobility, and we have emerging businesses under which solar is one of the emerging businesses at Redington. As I said, our service business, we are also having the service business through our subsidiaries, which is Ensure Support Services and ProConnect. So we are into all these logistics services, support services, cloud services, digital print services, and 3D print services. This is about our supply chain company. What is the strength? How we are strong in our distribution. Pan India presence, 180 plus warehouses in India, 6.7 million square feet of warehouse in operation. This is our growth story since for our supply chain since 2013. So Ensure is again a service company. These are the clients for which we provide the services through Ensure. This is about our other cloud solutions. Digital print services, 3D prints. These are financials, which we have a very strong financials based on which we are able to support the entire system integrators and EPC companies across the country, so they can bank on our financial credit ratings. So in terms of revenue, EBITDA, PAT, we have been growing in double digits since we have been stock listed. We are actually a stock listed company in India. In India, we do $2 billion plus revenue, and globally we are more than $6 billion company. These are regarding our foundation, our CSR activities at Redington. A lot of skill training, vocational training skills, employability skills, equipping activities, smart schools. So recently we have tied up with a lot of corporates for setting up smart schools across the country. Yeah, this is about our Redington. I would like to thank all the participants who have participated here, taken their time out to meet us. Maybe we can spend more time on the Q&A session. Any questions can be taken up.
Thank you, Mr. Pradeep, for sharing your useful insights. As I mentioned earlier, your strengths and personal connect with the end buyer plays a key role in the success of supply chain. It's time to engage with our audience. We have our next two poll questions coming up. So our first question is, how effective is the support you receive from DISCOMs in your region? And the second question is, do you think module prices are affected due to lockdown? While we wait for the results, I would like to invite Mr. Arijit Mitra to join us for the Q&A session. Mr. Arijit Mitra leads the solar distribution business, and he will be available to answer your questions. We've got the poll questions now, poll results now. This is, it says, I think 38% says not effective, and we have 42%, so almost 50% of the audience says it's effective. So that's a good sign. And with regards to the second question, module prices, I mean, we have an agreement on this for about 50%, from about 50% of the audience. So Mohit, would you like to add something on this? Do you think module prices are affected due to lockdown?
I think the temporary shift right now is that due to lower demand in Europe and generally globally, people assume that module prices will be going down. But one must keep in mind that the production side of module manufacturing was affected too. So the supply and demand gap will not be as huge as what people are presuming. Secondly, China has also upped its renewable energy target for this year, and they have gone up from 30 gigawatt to 40 gigawatt. And over many years, we have seen that China is able to deliver its numbers. So while there is, I won't deny it, there is a lot of talk about softening of module prices. We at Longi think of it as a temporary trend. Also at Longi, we do control a large share of the wafer market. And if you see the wafer and cell prices, they have not changed till now. So we do think prices will hold and demand globally will pick up. And demand in China certainly has picked up. So China is going to have a strong Q2 and Q3. And I think India and other markets will have a strong Q3 and Q4. Renewable is the obvious choice going ahead. Also, I want to bring up another point from Pradeep ji's presentation. Redington is a distribution powerhouse with strong financials. And as I mentioned before, we believe because module is a 25-year product, 25-year relationship, and 30 years in case of bifacial, financial strength is your best warranty, people. Because you want to work with a company that's going to be there for 25, 30 years. And we have seen cases in the past in the solar industry where companies that were there 5 years ago don't exist today. So, I mean, yeah.
Thanks, Mohit. I would now request all the panelists to come live. You can switch on your mic and cameras. We have a lot of questions, but as I mentioned earlier, that we'll be answering few because we don't have much time. Mr. Arijit Mitra, I'll start with you.
Thank you. Am I audible first of all?
Yes, you are audible.
Thank you.
Yeah. So we've received a question for you. What is your assessment about future of CNI business post-COVID-19?
See, Smriti, the thing is that manufacturing activity in India will anyway grow and it will grow exponentially. There is a stopgap that we are seeing for this COVID-19 situation. What we can see, and which most of our economic brains were suggesting, that India will see a V-shaped recovery from this kind of condition. Once we see that, the manufacturing activity will actually improve and will grow exponentially. And with that, all the manufacturers who are will grow and want to go into export sector, they would like to export their product, they will have to do cost optimization. And to do the cost optimization, it's an international trend that you have to go for solar, and solar is one of the key factors across the globe in manufacturing to optimize the manufacturing cost. So that will be a kind of exponential growth, which I think the industry will see.
That's great to know. I'll come on to the second question. How do you think that the market respond post-lockdown is open?
As I said, that the recovery will be V-shaped. We are expecting to see a surge in demand, and as Mohit was saying, that the supply and demand, the disparity between supply and demand, which is there right now, which actually will reverse once the lockdown is done. And the projects which are on hold during the lockdown, which will continue, and the new projects will come up. And we are also seeing that a lot of companies who are in process of improving their cost optimization, they are opting for implementing their solar project as soon as possible. So I believe that the surge in demand immediately after the economic activity starts in India will come.
That's a positive sign. Thank you so much.
I'm very optimistic about this situation right now.
That's really nice. Mr. Pradeep, I have a question for you.
Sure.
What are the criteria that an EPC company should consider while choosing a solar module brand?
Yeah, as I said, one is technology evaluation. They have to first evaluate technology based on their site location. Okay, what technology fits well there? What is the space available? Uh, whether the customer is demanding for the maximum output in the minimum space. So based on which they have to compare the efficiencies of the panels in the market, and then accordingly decide. And second factor would be the trend of the industry trend. So as you see today, the entire industry is moving towards mono PERC from poly. What once was a predominantly a poly industry just about an year or back, now that we have seen a very quick trend, very quick movement towards mono PERC. All the capacity is getting converted to mono, and poly capacity is going down. So the EPC companies should be also aware of the fact that going forward they want, if there is any warranty claim. So today they buy poly when the trend is towards mono. So they have to make sure that they get the support from the manufacturer if they use a technology that is slowly getting outdated or is going away from the market. Third is uh, the product quality, the existence in the Indian market, because you need the company, whether the distributor or the manufacturer from whom they are buying, how well they are entrenched in the Indian market, what is their strength in the Indian market, whether going forward for the next 25 years or 30 years, which is the product life cycle, whether they'll be able to, who will be able to support, whether the distributor or the manufacturer has the strength to support if there is any claim. And of course, availability, easily available at competitive prices. So prices and price should actually come in the last. There are a lot of things that they should secure and then look at the prices.
Okay. So what is the trend? What is the future trend that you see in efficiency of solar panels?
Yeah, as I said, the trend is today we are predominantly moving towards mono PERC. Even in between, we didn't have a bigger phase for mono, poly, mono PERC. That's how the technology has evolved. But we see that there is a fast shift towards mono PERC and higher efficiency panels. So people are now talking about above 400 watt peak, predominantly, which is
Yes.
which will actually take over the market. Yeah, but we still see that there are some lower efficiency modules that are still available. But going forward, I think we will only talk about maybe 450 and above. Today we are at 400 to 450. So probably we will only look at 450 and above for the 72 cell configuration. And in India, particularly, people only look at the wattage. The same 450 watt peak panel, which is 72 cell configuration. In 60 cell configuration, it could be a 350 watt peak panel, but the mindset and the understanding of the concept is a bit skewed. So 60 cell or a 72 cell panel, the efficiency is what is more important than the rating of the panel.
Okay, thank you very much.
To add to that, the adaptability of technology is also very important, because once the narrative is also float around with the wattage, what we are also trying to, point out that the degradation is also a very big factor. Once you have a better a module with a better degradation, then your LCOE goes up drastically, and which larger developers have started understanding, and they have actually adopted this technology very, very open-heartedly. So I believe the CNI sector will also slowly understand that, and they will actually go with a better degradation modules.
Thank you, Arijit, for adding your insights. I have few questions for Mr. Pavan Mathur.
Please.
Yeah. So I've got a question saying, is HIMO4 BIS certified?
Yes, it is BIS certified. HIMO4 new is under the process, and we'll get it soon. HIMO4 new with 9 bus bars. HIMO4 we have the BIS certification, and because of this corona pandemic, we got stuck. Otherwise, we would have received our certification by now. So
nine bus bar we'll have July.
9 bus bar. Yeah. For 6 bus bar, yes, we have the certification.
Okay, that's
6 bus bar we have BIS, 9 bus bar after July.
Yeah.
Okay. Okay. So another question is, if we reverse the bifacial module, will it be able to generate the same amount of energy?
No, it will not be able to generate the same amount of energy, because if you see the way the cell has been made, the top side is N layer, and there is depletion region, and then there is a lower layer of P type, which is actually thick. So if you reverse it, then the photon which is coming from the sun will first have to enter from the P region. Right, so it will be facing major challenges because P is thick and as compared to N. So that is the reason it's not going to generate that much as compared to the N layer, which is if that is on the front part.
So I have another question which I'll open for all the panelists. How bifacial module is compatible with microinverters? Would you like to take it up, Pavan?
With microinverters.
Bifacial module is like any other module. So there's nothing special about the module. In terms of power generation, you have more power generation from the backside. So what we quote is the front side power. What you get from the backside is additional gain. So it's not different from any other module in terms of...
The calculation should be done with keeping, if you see the data sheet of our module, in the backside, there is a clear table which shows that if the bifacial gain is this much %, then what will be the VOC and everything. So when we do the site calculations, we first have to understand what actually is the bifacial gain which we are going to get. And based on that, we have to decide, we have to do the calculations for other things. Right? Yeah.
Okay. I'll put across a last question. What is the value of LAM losses in your modules? I hope I got that correct.
Is it IAM?
Yes, I'm sorry.
Okay, I read the question. No problem. It's incidence angle modifier, IAM. So our IAM losses are, they depend a lot on the site you choose, right? So heavily dependent on the site. In our cases, what we have done when we did our calculations with our pen files is actually the best, one of the best. It ranges from 0.8 to something around 1.5. So it's really less if you compare our modules pen file with other competitors. And also the other losses also. So we have really worked hard on countering the losses in the module. As Mohit has rightly spoken in his presentation, that we have worked a lot on R&D. So because of all those small changes like changing the dopant and other things, we have worked really hard on improving the efficiency of the module and reducing the losses. So IAM losses, and yes, they asked, somebody also asked this thing that do we have a third-party verified pen file or not for this IAM losses? Yes, we have a third-party verified pen file losses for pen file available.
Okay. So I think we like to close this now. We are running out of time as well. So I thank all our panelists.
I
Longi
just want
Solar.
some closing remarks from Arijit
Yeah,
J and Pradeep
sure.
to end it. Yes, because I think they have a lot of customers.
Yes. Can we have thoughts from Mr. Arijit, please?
I'd like to thank everyone for participating in this webinar of ours. I believe this is the time when we get some time for learning and understanding about the technology upgradations. And I think Pawan's contribution was the most in this webinar. And if you have any questions, we can always answer them offline. We have so many questions today. We'll not be able to answer all of them in this session. We will take out this Q&A and we'll reply you individually by mail. Thank you very much, all of you. Pradeep ji, over
Thank you,
to you.
Arijit.
Yeah. So as I said, we have been associated with Longi since 2016. So we would continue to take our partnership as long as it can go, and try to deliver the technology and the quality products to the system integrators in India. Because our intention, our goal is always to take the technology to the end user. End user has to get the benefit of the technology. So Redington is always a technology agnostic player. So we only keep the basket open and say this is what is the advantage, these are the disadvantages, and mostly we do our homework and we ensure to see that we work with the reputed brands. Longi, we have any project that requires Longi modules, we do have stocks that are already in India. So we will be able to happy to offer. We can get in touch with our team. We have a team across the country. Through Longi or directly to Redington is okay. So I would like to thank all the attendees, the participants, for taking time out. Any questions can be taken one-to-one also. Thank you.
Thank you, Mr. Pradeep.
Thank you.
So I thank you all for taking out time and having this great interaction to share knowledge and insights. Thank you, Longi team. Thank you, Redington, for joining us today. We have many more interesting sessions planned in the coming weeks. So I'll see you all again in our upcoming webinars. Let's learn during this time, and thank you again.
Thank you. Thank you.
Thank you.
Thank you very much.
Thank you very much, everyone. Please be safe.
Thank you.
Thanks, Mohit.
Thank you.